Okay, good day. Today we'll discuss about planar kinematics of a rigid body. So for the previous topics, we focus on uh, analyzing the motions of a particle. So meaning the forces is concentrated in one point. Now for this chapter 16, we'll be studying about motion of a plane. Okay. So the objectives for this chapter is to uh, the student must be able to classify various types of rigid body planar motion. Okay. Also, to investigate rigid body translation and angular motion and motion about a fixed axis. And also, we will be studying about planar motion using absolute motion analysis and relative motion analysis. Okay, so what are the three types of planar motion? So it is classified into translation, rotation about the fixed axis, and general plane motion. So for translation, you have rectilinear translation and curvilinear translation. So translation is a type of motion when a line in the body remains parallel to its original orientation throughout the motion. So as you have observed, you have 2 points in a body, two or more points, no? For simplicity, duha lang ang ipakita diri na. So na kay duha ka points, and then pag move aning nga body, it will remain parallel or linear. So it is called rectilinear translation. Now kung ang movement po sa body is uh, it produces a curve now between ani nga points, this curvilinear translation. Okay, rotation about a fixed axis is when a rigid body rotates about a fixed axis. So this is the fixed axis. And all the particles of the body, except those lie on the axis of rotation, move along a circular path. Okay, and also, the third one is the general plane motion, wherein it is a combination of translation and rotation. Okay, so these topics are very useful in analyzing in the design of gears, cams, and mechanisms used in many mechanical operations. So one of example is this one. This is a part of a machine, and this actually is a 4-bar mechanism that consists of a piston and cylinder, and this is a flywheel. Okay, so ang movement ani is just rectilinear translation. This one is a rotation about a fixed axis kani, as well as this one, and this one is a general plane motion kaning arm, or and this one is a curve represents a curvilinear translation. Okay, so first let's discuss about translation. This is just mga na-learn nato no from previous chapter 12, 13 can be applied in this topic also. So first, consider a rigid body. So this is your planar no rigid body, and in that rigid body you have points, many points actually, because a plane is composed of many points. And then just consider 2 points in the body. You have A and B. Okay, and also you have a fixed coordinate system. So, important na dyan siya para muna ito ang reference. And then you attach a translating coordinate system. Kani, naka-attach niya sa imong body at point A. Okay, so therefore, the position of A and B is denoted by this position vector R sub B and R sub A. mo ni mag-define sa imong position. Now, ang kaning relative position R of B with respect to A, so R of B with respect to A, meaning gikan sa A, uh, this is your this this represents the position of A with respect to B. Now, by vector addition, R sub B, this one is just the addition of R sub A plus R sub B with respect to A. Again, dali pwede nila lang mabali-bali. Okay. Now, take note, kaning ang point sa imo ang body, sa imong plane, no, pag move ano niya, mag-translate na siya, dili na mo change. R sub B over A, ragid gyapon ng length ano niya. Okay, mag-move ram na siya. Translation. Okay, so if we get the velocity of these points A and B, so we'll just apply the first derivative on this equation. And then, so derivative of R sub B with respect to time is velocity of B is just equal to velocity of A. Now, ang derivative of R sub B with respect to time is equal to 0. Why is that? Because di man mag-change. So, constant man siya. So, man 0. Therefore, the velocity of B and A is just equal. So, unsay pasabot ani niya? So, ang pasabot ani niya within a similar nga plane, ang mga points no under sa similar nga plane travel at the same velocity. And also, if we get the acceleration, we'll just differentiate this one. So, the velocity and acceleration of points in a planar body is just the same. So, mga pasabutan na niya. Okay, so the kinematics of particle motion in chapter 12 can also be used to specify the kinematics of points located in a translating rigid body. Okay? Ma-apply daw itong mga equation niya po. Let's proceed with the rotation about a fixed axis. So when a body rotates about a fixed axis, any point P located in the body travels along a circular path. Okay, so kung naakay point diri yung mong body, so ang travel ano niya is a circular path din na siya. Okay, so the angular motion, so ang position aning point P nimo is denoted by this position vector R. No? And ang ang displacement is denoted by this one, d theta. No? Kung mag-move ni siya, kung mag-change niya ang position ani, it will result to a change in d theta or the angular displacement. Take note that one revolution is equal to 2 pi radians. Okay, by the way, ang direction aning d theta no is dili paana but instead paana pa going up no using the right hand rule. Okay, so as well as the angular velocity. Now kung i-differentiate nimo ang displacement with respect to time, you'll get the angular velocity which is just d theta over dt. This is the angular velocity, omega. Or this represents how fast is the angular displacement changing with respect to time. Again, ang direction anak niya is just the same sa imong d theta. Going upward also. As well as the angular acceleration alpha. Now, kung imo na differentiate, you'll get alpha which is d omega over dt, angular acceleration. Going upward, gyapon ni siya. Direction, no? Okay. We have a notation here. When indicating the angular motion in the shaded plane, we can refer to the sense of rotation as clockwise or counterclockwise. So in this book, we have arbitrarily chosen counterclockwise rotation as positive. Okay. So since ang omega nimo is just dt over d theta over dt, kung imo nang i-plug in dere, you will get d squared theta over dt squared. And also, if we want to get the relationship between theta, angular velocity, and angular acceleration, imo ning i-eliminate ning dt, no? Eliminate na nimo gikan dere. So makuha nimo ni kani alpha d theta is equal to omega d omega d. So this is analogous atong ADS is equal to VdV for rectilinear motion. Again, so if the angular acceleration is constant, pwede nato sila i-evaluate, no? Just like atong mga kinematic equation. So ang counterpart ato is kani omega is equal to omega theta plus angular acceleration times time and so on, no? We will not derive this one because dali raman kayo ni yung raman i-integrate. It's like what we did in the rectilinear motion na topic. Okay, so if we have a point P in a rigid body, what is the position and displacement? So makuha nimo ang position na is denoted by vector R and the displacement is denoted by kani ds, no? Arc length ds is equal to r d theta. Okay, what is the velocity of point P when mo travel na siya og omega? So makuha ra naman siya v is equal to omega r. Okay, v is equal to omega r. Giaham na gikan imo ra ning gi kani imo ning gi differentiate, no, with respect to time or i-divide nimo by time. Kung i-divide nimo ni by time, you'll get the velocity is just equal to omega r. Okay, kung gusto ka og vectorial notation, pwede pud kani mo gamiton b is equal to omega cross r sub p. So unsa ning r sub p kani nga line? Kani nga line. Okay. Dili ni pwede mabalin, no? Dili ni pwede r sub p cross r. It should be omega cross r. Now, ang magnitude ani is just the same kani mo ni magnitude niya, omega r. Imong velocity. Ang advantage lang ani kay ani siya direction also. Okay? So the velocity is just omega cross r. Okay? And the acceleration, ang acceleration kung imo ning i-differentiate with respect to time, ang acceleration would be compose man ni siya sa since ga-travel man ni siya og curvilinear man gud circular man gud yung motion, so that is why naa kay component tangential and normal. So for tangential acceleration, imo ra ning kani imo ra ning i-differentiate, so this will just become alpha r. And the normal acceleration is v squared over rho man to. V squared over rho. So, what is v? So, mahimo rang v squared over rho. So, kung square ni mo ni, mahimo ning omega squared r squared divided by r. So, mahimo ning omega squared r ang normal acceleration. So, these are the tangential and normal acceleration. May mga magnitude nila. Okay, kung gusto ka og vectorial notation, vectorial nga pamaagi, pwede ka niyang gamiton. Acceleration is just equal to alpha cross r sub p plus omega cross r sub p, or this is equal to ani? Alpha cross r minus omega squared r. Kani nga term, this is just equal to negative omega squared r. Okay, so we will apply this one for kaning analyzing kaning gears. So sa gears, no, sa gear duha ni siya ka uh, circular nga object, no. Mutra ang travel ani nila is rotation about a fixed axis. Kaning gears C and B, no. Gears C and B. So unsay ang the same ani nila is the same ni sila og velocity. Now the same og velocity. Remember that velocity is omega r, right? Therefore, omega b r sub b is just equal to omega c r sub c. No? But dili na sila the same og acceleration. Dili sila the same og acceleration. Okay? And the same ni sila og tangential acceleration. Okay? Ano the same sila og tangential acceleration, but dili sila the same og normal acceleration. Ano man kay sila the same og normal acceleration, kay lahi man sila radius good. Okay? Remember nga ang normal nimo is kani, right? Anyway, we'll have an example this one later on. Okay? So, let's have an example. This one. The motor shown in the photo is used to turn a wheel. So this is the motor, this is the wheel. And turn a wheel and attach blower contained within the housing. Okay? The details are shown in the figure. If the pulley A connected to the motor, what is the pulley? Okay, this one. Begins to rotate from rest with a constant angular acceleration alpha to alpha a is 2 radians per second square. Determine the magnitude of the velocity and acceleration of point P. So kani ang point P on the wheel after the pulley has turned 2 revolutions. Assume the transmission of the belt does not slip on the pulley and wheel. Okay, so we'll have an example, and in this example, we have a motor that is used to turn this wheel. And if the pulley connected to the motor begins to rotate from rest, so initially, this is the pulley. This one, pulley is attached to the motor. So if the pulley begins to rotate from rest, okay, so theta A 0 is equal to 0, no? With a constant angular acceleration. So, angular acceleration alpha is 2 radians per second square. Determine the magnitude of the velocity and acceleration of point P. So we're asked to find the velocity and acceleration of point P. Okay? The velocity and acceleration of point P. On the wheel after the pulley has turned 2 revolutions. So after theta A final 2 revolutions. Okay? So nag-move ang imuang pulley. So this is the pulley, 2 revolutions. Assume the transmission belt does not slip on the pulley and wheel. Okay? So let's define what are the types of motion that presents here. So for this wheel, this is rotating about a fixed axis. So this is a rotation about fixed axis as well as the pulley. Okay? So we are asked to find the velocity of point P. So velocity of point P is just omega P cross RP or multiplied by the radius. Radius. So ang radius ani is 0.4 meter while ang pulley, the pulley is 0.15 meters. Okay, so in order to find the velocity, we need to find the angular velocity of point P. Now, point P, this one, and point B, same sila radius, so same ni sila velocity. Okay? Kaya isa raman po ni sila isa ka rigid body. Okay? And then they have the same radius. So, velocity of point B is just equal to velocity of point P. Is just equal to omega B times R sub B. Okay? So, therefore, we need to find the velocity of B. Dili man given. Okay, so we need to find first the velocity of, angular velocity of point B. Okay? Since ang kaning imo ang point B is connected by a pulley sa imong by a belt sa imong pulley A, therefore unsa gali ito? Velocity of A is just equal to velocity of B. The same ra ni siya sa nakay duha ka gear diha, A and B. Velocity of A is equal to velocity of B. Tangential acceleration of A, tangential no, is just equal to tangential acceleration of B. Normal acceleration of A is not equal to normal acceleration of B. Therefore, ang total acceleration of B is not equal to, equal lang ang tangential. So, ang tangential diri. Tangential nga part. Belt and gears, same ra na sila. Okay? So, therefore, pangitao na to una ang kani kay mo man yung given, what is the velocity of A? This is just equal to omega A times R sub A. Given ba ang omega A? Dili, but given ang angular acceleration. Based on the angular acceleration sa mga kinematic equations, given man ka og angle, so omega squared plus 2 alpha A theta A minus initial. Tama ba? Okay. Since ngayon nga the pulley starts from rest, so rest so 0 ni, as well as this one, no? Initial angle is 0. Therefore, may tabuan ni is mayroon na lang ni 2 times 2 rad per second square. Ang angle nimo is 2 revolutions. So we need to convert this one into radians. So 100 2 pi radians. Okay? Hindi mo na lang lining. Answer na will be omega A is 7.09 radians per second. Okay? So we now find omega A. So makuha na nato ang velocity sa point A. So velocity sa point A is 7.09 times RA. RA is 0.15. So this becomes velocity of A will be 1.06, right? Unit. The unit is meter per second. Okay. VA. Again, this is just equal to velocity B. So equal reference is the velocity B. And velocity B is just equal to velocity of P. So muna ni ang answer. No? Or, kung hindi mo satisfied, pwede po niyo kuha na wala naman isa sa omega B R sub B. No? Kuha ninyo una ang omega B. At saan pagkuha? VA is equal to velocity B. So, omega A RA, omega B RB. Kuha ninyo ang omega B diri. Omega A RA over RB. Pero anyway, kanina largo eh. Same room na sila. And then, well, we need to find the acceleration. Acceleration of point P is just equal to tangential acceleration of P plus the normal acceleration of point P. Okay, as I have said, acceleration of point P is just acceleration of point P is just acceleration of B. Nga naman, kay again, same rami sila radius dere. Okay, so this is just equal to acceleration tangential of B plus the normal acceleration of B. Okay. The tangential acceleration of point B is just alpha B RB. Alpha B RB. Tama? And again, tangential, recall no? Tangential acceleration of A is just equal to tangential acceleration of B. Equal lang siya sa alpha A RA. So, kanina na itong kwaon, alpha A RA kay given man. So, you have 2 rad per S square times RA. What is RA? 0.15 meter. So, ang answer ani would be 2 times 0.15, 0.3. Unit is meter per second square. Again, this is the tangential acceleration. Wala nang the normal acceleration of point B is just omega b omega squared RB. Okay? So what is omega B? Ang omega B is makuha ni mo diri. Omega B is omega A RA over RB. So omega A is ano ito? Ay, nawala. Rest na ako. Omega A is 7.09. RA 0.15 over 0.4. This is just 2.659. Unit is rad per second. Okay, so 2.659 squared times 0.4. Answer would be 2.80828, no? Meter per second squared. Okay? Okay, therefore, acceleration of P is just square root of 0.3 squared plus 2.828 squared. Ila answer ani? Answer is 2.84 meter per second squared. Okay? So that's it. So unsay atong gibuhat gani? First is we define what is the type of the motion. Okay. Diha mag-base ang ang approach, ang atong equations nga gamiton. And then for pulley, no? Pulley or pulley. I mean kanang belt, no? Belt tawag ano niya is belt transmission man eh. Belt imong gamit sa pag-transmit sa power. So velocity ani is equal to velocity of point B. Ang tangential component sa acceleration for A and B also is equal. So maura na siya. Okay? And also solve as many problems as you can.